Alright, welcome back everybody. My name is Dustin. In the last video, we ended up making the font class and the font loader. And there was also a small challenge to see if you can add the loading of the fonts to the asset manager and also try to do the load font from memory. If you're able to do that, that's awesome. Post that in the comments below. If you weren't able to do it, no worries. We're going to go over that today. And we're also going to create the text batch renderer, and we're going to add in the draw functions for text to the renderer. But before we start that, I ended up doing the Rect batch renderer and the circle batch renderer. I asked as a small challenge to see if you guys could do that yourselves. And we're going to go over today on how I did that. We're not going to go type out the implementation. I just did it. I'm just going to show you what I did, and you can grab that from the GitHub repository later on. All right, let's get into it. So as you can see here, we made a lot of different changes. So we added to the renderer bindings, the scripting system, and all these other changes were made in order to get these rendering to work. Also, I ended up altering the line batch render slightly. I think it looks cleaner this way. So let's take a quick look at the Rect batch render. The Rect batch renderer, we basically did it the same way as the other ones. We have our batcher, and we have a Rect batch and a Rect glyph. So inside there, we have our generate batches, initialize, etc. And we have our two draw rect functions. So if we just go to generate batches, you see here that our rect glyph is going to have a top left, top right, bottom left, bottom right. And we're basically doing the same thing, and we're just batching up our vertices. This one only has two attributes. We have our position and our color. Unlike the sprite batcher, which is basically the same thing, but this one doesn't have a texture to worry about. This one's only using the position and the color. So it's basically the same thing, does the draw elements based on our indices, and we add in our rects basically the same way. So if we go to our circle batch renderer, it's basically the same thing as the rect batch. We're actually using the rect batch because a circle in this case is just a rectangle, and any pixels that are outside of the circle values are just discarded or not drawn to. We have our circle glyph. Let's quickly look at the circle glyph. Circle glyph has a circle vertex, which has a top left, top right, bottom right. Same idea as a rect. Instead of using the rect glyph, which is just a regular vertex, let's take a look at the circle vertex. So the circle vertex has a few things. It's basically the same. The only difference is it has the line thickness. So that's kind of like if you want a donut or something like that, we use the line thickness. Or you can have a filled circle if the line thickness is 1. So let's go back to the circle batch renderer. So here in add circle, it's the same idea as adding a rect or adding a sprite. We're just adding in our vertices and our line thickness and stuff like that. And then up here, it's exactly the same. So we're adding in our circles. So if it's not 0, we add in place it here. And then we just add it in and increase based on our number of indices. Exactly the same as rects. And we're drawing it the same way as well. The only difference is our initialization. The way that we're initializing it is different. We have our position and we have UVs. We treat our UVs, we need our UVs so we know where the circle is and what the values are going to be. And then it has our color and line thickness. And these are all the vertex values that are sent to our shader. So let's take a little look at our circle shader. So we actually have we have our color shader. I use this for the rect. And it's very simple. It's just vertex has our projection, U projection, and we have our color. Basically, it's just taking in the color and sending it out. The circle's a little bit different though. So if we go to the circle shader, it has our 4 attributes that we sent in. Our position, UVs, color, line thickness. And we want to send out these here, our frag UVs, frag color, and frag line thickness. Here, so we have our position is equal to our projection multiplied by the vec4 and takes in our A position. Frag UVs are just our input UVs. Frag colors, input color, and line thickness. And then we go to the circle shader fragment shader. So it's taking in our fragments, our color, our UVs, our color, and our line thickness. So the first thing we do here is get the distance, and that's just 1 minus the length of the frag UVs. Now, the length just calculates the length of a given vector. So we're sending in our UV vector here. And then we get the f width of our distance. The f width just returns the sum of the absolute value of the derivatives in x and y. This basically tells you how much variance there is between each pixel and its neighbors. It's kind of like an edge detection. And then we find our circle. We're using smooth step from 0 to WD that we just calculated up here, and our distance. We also multiply this circle here again by the smooth step for the frag line thickness plus WD and the frag line thickness again. What this does is, it does the same thing with interpolating the values determined above. We do this to remove any pixels from the center of the circle, leaving a kind of a border if needed. This can be controlled by the user. You can either have a filled circle or you can have circles that are not entirely filled. And anything that's 0, we just discard it here. All right, so we also did the bindings. So if I go here to the under bindings, so we have a few bindings that we added in. We added in our circle bindings. And I just added in the DrawRect function, which calls the DrawRect function in the renderer. And the DrawCircle function, which also calls the DrawCircle function in the renderer. So these functions, basically, they're not actually doing any of the drawing. What they're doing is they're adding in a primitive to the vector of primitives, and then that is running through the batch renderer itself to draw. So if we go here to the DrawCircle function, so all it's doing is it's constructing a circle and doing a pushback here to these circles. And then down here in our circle batch, we add all our circles to the batch. So here it clears the batch, adds it in the circle, and then it ends up rendering the batch. And then after each draw, we end up calling the clear primitives. If we go into the application.cpp, we're calling clear primitives at the end of each call, because if not, it'll just keep adding in a new primitive to the vector, and the vector will just keep growing and growing. So if we go to our main.lua right here, we're just calling these inside of the render function for our main.lua. So we have our update and our render functions. Now we can call this outside of it, out here, but we won't see anything because it'll just draw the one time. And then, so if we just actually run this, it won't show anything because it's going to draw it the one time and then clear the primitives, so there won't be any more primitives. So yeah, so this is just the map that we were loading previously. And you see we don't see our primitives, okay? But if I take these again and draw it down here, run it again. And it's drawing in a circle and some other shapes. We have 2 lines. Now, I did think that I had a memory leak, because when I was running this previously, the memory just kept going up and up and up. And I kept thinking that it was the C++ calls, and I couldn't figure it out. It took a long time to figure out. But in reality, what it ended up being was my Lua state was holding on to some references to these. It didn't call the garbage collector when I wanted it to. So it wasn't calling based on these draw calls. So over here in our scripting system, so if we go to our scripting system, and down here in our update and render calls, so now I'm calling the garbage collect function after each render. So after each render and after each update, we call the garbage collect. This way, if there's any stragglers or extra stuff that's left in the Lua state, we do collect the garbage there. That took care of that memory leak. It wasn't really a memory leak, it was just Lua holding on to things that weren't being used any longer. All right, so that's all the changes that I made in the background, and that'll be at the GitHub repo for you guys to look at. And for today, let's go back and continue with the fonts and text rendering. So if we go to our asset manager, we can now add in our fonts. So we'll just add in our fonts here. Font.h, and we're going to do the same thing. Map of fonts. Add texture. We can just copy both of these. Add font, and this will be font name. Font path. And we don't need pixel art, but we do need a float font size. And we'll have that default to 32. And this will be get font. Cool. Checks to see if the font exists. Cool. And we're also going to have another one that's add font from memory. This takes an unsigned char pointer. That's the font data. Cool. All right, let's create these. All right, so to load the font, we just want to check to see if the font exists. And in reality, right here, we end up making an iterator, but we don't end up using the iterator. So we can actually change this to contains. So if the add fonts, we want to go if mmap fonts.contains font name. We're just going to have an error here. We'll just copy this error. Oops, not cut, copy. Put it in here. Return false. Fail to add font. Already exists. Cool. So now we need to add in our font loader up here. Font loader, and we can go auto p font is equal to Scion rendering font loader create font name, or sorry, font path and font size. So now we want to check to see if the font is null pointer, if not p font, and have another error. Fail to add font at path to the asset manager. Font name and font path. Return false. And if we're good here, we can just go map fonts dot in place font name std move rp font. All right, and then just return true. That should create and in place the font for us. And we can basically just copy this. Let's make this a bit bigger. Copy this and put that here. Paste. This one, we want to say create from memory. Now we haven't done this one yet, but that's okay. That takes in the font data. So this one won't save from the past. Fail to add font from memory. Get rid of the path. Cool. Now we still have to do this function, and we'll do that shortly. So let's just do the get function now. So with get, we've done this before. We can just get an iterator. So we basically see our get texture. Let's just copy this. Go down here to our get function. Paste that in. Map fonts. Find font name. Map fonts. Change this to font iter. Fail to get font. Font name. Font iter second. All right, that's basically all we got to do for those. That should work as it is. So now actually while we're here, let's go fill out this create from memory function. If you were able to do that, good for you. And if not, we're going to do that right now. To create the font from memory is a little bit easier. All we have to do is go unsigned char pointer bitmap is equal to new unsigned char width times height. And we can go auto. Data is equal to, remember we're using void pointer, new stbtt baked char of 96 characters. And we want to go stbtt bake font bitmap. That takes in our font data that we're sending in. That takes in 0 for offset. The pixel height is our font size. Sorry, it's font size. Then it takes in our bitmap as our pixels, the width, the height. Then it takes in 32, 96, and it takes in our data. Cool. That same with here. I don't think we need to do that. All right. And then once we have all that, we can actually just do the same as this. Copy all this. Paste that in here. Can't use bitmap.data. We just use the bitmap. And once we've done that, we can delete our bitmap. Make sure we release our resources or allocated memory. So delete bitmap. And then std make shared font. Takes in our font ID, the width, height, font size, and the data. And that should work for us. Okay. So now that we have our creation of the font and then we have our asset manager, we need to bind this function here in our asset manager. So we'll go back to the asset manager and we want to be able to add our fonts in. So let's go add font. Now the font from memory one, we won't be doing from here because that's basically something that you want to have already as a file in your compiled C++. But this one we can add it in from the path. Const std string, preference, font name, const std string, font path, and then we can put the float font size. Let's return asset manager add font. All right, that's not happy about something. Oh yes. Add font, font name, font path, and font size. Cool. So we're going to need to add in a font to our assets here. So what I'm going to add, I already have a TTF file that I could use for me. So in the editor, in the assets, I'm just going to paste this in here, is another folder for fonts. And I have this font that I got here called Pixel. I got it off of OpenGameArt and it works perfect for me. So we're going to want to load that in. So we're going to need the path and we'll try to load that in. Let's just go to the application to see if we can load that in. So we go to application.cpp and then up here, anywhere really in our initialization, we're just going to add it in temporarily. So if not asset manager dot add font, and that is assets font pixel.ttf. Oh, and we're going to load that in as, sorry, I forgot what I was doing. We're going to call it pixel, just pixel. And we'll leave it as default 32. So if not, Scion error, fail to load pixel. And we're going to return false. We don't want to keep going. We want to debug from there. So let's see if we can just at least just load the font in and debug. All right, so it looks like we have an error. So let's see what's going on here. Blah, 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 logger, asset manager, this here. So P font was empty, so we were unable to create the font. Wow. Those were just strings. They should have worked fine. Well, let's run it again. See if that happens again. Cool. All right, so unable to create the font, unable to read buffer. So it says right there, unable to read buffer. All right, so in assets, fonts, fonts. Run that again. Awesome, so we're able to load our font successfully. That's great. I'm not sure what that's doing now. That's something cool, but it's doing something else. Interesting. We'll look into that later. The goal for today is loading in the fonts and being able to actually do the font drawing. Okay, so now that we're loading the fonts, we need to see if this is working by actually creating a text batch. In order to create the text batch renderer, we're gonna have to add some new batch types. So let's go to our batch types in our essentials and here in our batch types. Now we'll just put them all at the bottom here. So we're gonna have a text batch. So let's do that here. So we'll go struct text batch. Now with text batching, I'm going to use the vertices rather than the indices. So let's go GLUint, and that's going to be our offset. Now we're going to have our num vertices. And we're also going to have our font atlas ID. Cool. Now that we have our text batch, we're also going to need a text glyph. So struct text glyph. That'll take an std string for the, we'll call it text string. That's going to take in a GLM vec2 per position. That's going to take in a color, because the text is going to have color. That'll just be a default color. Well, white. It's going to have the model. And we're going to have that shared pointer to the font. And that's going to be start as null pointer. Let's include our font. And we're also going to need a wrap. So float wrap. I'm going to call it wrap. So that's basically the text wrap. So if you have a line of text, it's when you want it to wrap around to go down to the next line. So start it off at 0. 0 means it won't wrap at all. It'll just go forever. We'll go over how we're going to do the wrapping when we get into the text batch renderer. And there's also going to be a padding. And padding. So how much padding do you want between the words? Cool. So that's our text glyph. All right, so now let's do a text batch renderer. All right, so up here in our core, we'll go add new item. And that's going to be hfile, the text batch renderer.h. And this is going to include our batcher. And it's going to include our batch types. And we're going to have our name space, Scion rendering. And it's going to be a class text batch renderer. And that's going to be public batcher. And it's going to have the text batch and text glyph. Cool. And we're going to have our private initialize. Sorry, that's void. And then virtual void generate batches override. Now override is optional. I just like putting it in. Public TextBatchRenderer. So everything's basically the same as the other batch renders. However, we're going to have our void add text function. That's going to take in a const std string reference, not string buff, string reference text. I don't know why it doesn't like string right now, but we'll add that in. So the text that we want to actually use, it's going to have the const std shared pointer of font, and that'll be a reference font. And then glm vec2, we can make this const as well. Const reference position. Let's go down to the next line. And we'll have the int padding. Padding is going to equal to 4. Float wrap, that's also going to be equal to 0.f. Color, it's equal to default color. And then the model. So glm mat4 model is just going to be a glm mat4. So basically an identity matrix. Cool. Put that back up there. All right. So let's make all of these. Awesome. So that created our TextBatchRenderer.cpp for us. Let's go into that now and do our little thing here. So in our initialize, we're just going to be using the vertex for that. So we're going to go set vertex attribute. That's 0, 2, GL float, size of vertex, void pointer, offset of vertex, and position. That's for the position. And then we need the color and then the UVs. So let's go UVs. And this one is 2, 2. This is 1 and 4. This is GL unsigned byte. GL unsigned byte. And that's color. And it's also GL true here because we want to normalize. Cool. And before we do generate batches, because that's a big one, let's just do the other one. So here we can initialize our batcher, and that is false. We want to call our initialize. In our end, we just want to go if mglyphs is empty. We're just going to want to return. And if not, we're going to generate batches. All right. Then in our render, we're going to want to do the same thing, but for batches. So if batches is empty, just returns, no need to continue. Else we want to enable our VAO. And we want to loop through all of our batches for const auto batch. GL bind texture, GL texture 2D. That should be an underscore there, sorry. Then we want to go batch font atlas ID. Don't know why that did that. Atlas ID. And we want to draw arrays here. GL draw arrays. Draw arrays. GL triangles. That's batch offset and batch num vertices. Cool. And then just disable VAO. Awesome. That's all we need for this one. This one we're using the draw arrays because we're using the num vertices rather than num indices. Okay. So add text. We're going to do auto new text glyph is equal to std make shared text glyph and that is a text glyph dot text string is equal to the text coming in dot position position. Let's go grab that really fast because I don't know the order. So we'll grab all this, bring it over to our text batch, just paste it here for now, and we'll delete it in a second. So position, so the color. So go to color, model, let's equal to model, and font is equal to font, wrap to wrap, and padding is equal to padding. Awesome. Now we should also put in a check here as well. So if not font, just return. Because if the font's null pointer, we don't want to try to make the glyph. There's no point to anyway. Cool, so we have our glyph, then we can go m glyphs dot push back std move our new text glyph. Awesome. So there's that. We can get rid of all of this. Okay, so we're almost done. Now it's the big one right here. So there's a lot more to generating a batch for the text because I want to be able to add in the wrap capability as well. And we want to be able to chunk the text into different various lines of text. So that's what we want to do here. So we're going to create our offset. So GL uint offset. That should be capital L. And this can just start at 0. And then we can have our prev font ID, just in case there's multiple types of font. Then we can have int current fonts. Then we want to get the number of characters that we need to do. So we're going to call that a total. That'll be a size T. That'll be our total. And we'll just start that at 0. And we're going to have our current vertex. Start that at 0 as well. And now we're just going to loop through each glyph that we have and get each character. Does that make sense? So we want to go for const auto reference text glyph for each text glyph of glyphs. We want to loop through and we want to add the size of their string to this total. So text glyph dot text string dot size. I want all of the characters size. So we're adding up the total characters. Add up the total characters. Okay. So now that we have the total, we can actually resize our vectors. We can go std vector of vertex, and we'll call it our vertices. We've done this before. And we can go vertices dot resize total times 6. We're doing times 6 because that's the number of vertices we're using instead of indices. Okay, so now we go for const auto reference text glyph in mglyphs. All right. So for each text glyph, we're going to have text chunks, and we're going to have a text folder and a temp position where we want the text to be. Okay, so we're going to go std vector of string, and this will be our text chunks. So a chunk is basically a line of text. Okay, and then we're going to have std string text folder, and it's just going to start as an empty string. And then we're going to have a position glm vec2, and we'll call this temp pause. That's going to be equal to our text glyph, not this text glyph, this text glyph, and that's the position. Position. Oh, not vec4, sorry. I hit 4 again. Vec2, position. So the first thing I want to do is check to see if our wrap is greater than 1. So text glyph wrap. If it's greater than 1.f, I want to assume that it's much larger. So we can, here is where we will chunk our text. So create the text chunks for each line. Okay. Else, we're just going to basically take our text chunks and just push back the entire glyph. So text glyph, text string. So if we're not wrapping at all, we're just shoving the whole thing into the text chunks. I'm using the text chunks here so we can just use the same thing down below. I don't have to keep adding in different stuff. Okay, and then we want to reset the text position. Because if we got here, that means it's going to the next glyph or the next line, and we want to reset the position. And then we go temp pause is equal to text glyph position, because that doesn't change. And then we go for const auto reference text string of text chunks. So for each text string of all of our text chunks, then this is add new text sprite, basically, we'll call that. So for each text string, we're going to want to get each text character. So we go for const auto reference character in text string. Now we want to get each glyph. So auto glyph is equal to text glyph font get glyph of the character that we're sending in, and we're sending in temp pause. So we'll have our first triangle, and that's going to be vertices at current vertex plus plus is equal to a new vertex. Whoops. And then we're going to have our position is equal to text glyph model times BLM vec4 glyph dot min dot position dot x glyph min position dot y 0.f and 1.f. That's our position. Then we're going to have our UVs. That's equal to glm vec2 glyph dot min dot uvs dot x glyph dot min dot uvs dot y. And then last, our color. So you go to text glyph color. So we can just copy this. So that's the first vertice of our triangle. So we need to do 3 vertices for each triangle. So we can get rid of this. Everything's the same here, except this changed to max position. Max position.x. And this stays at min position.y. Then our UVs is max and min. Max and min. Let's copy this. Paste. So position for this vertice will be max position x, max position y. And max for UVs. Max and max. All right, cool. Now we can do our second triangle. Let's just copy the whole bunch. Change the name up here. Second. Okay, so our position for this one is the same as the top, min, and then min and min, because it represents the same point. So this one is going to be different. It's going to be max position x, max position y, max and max. And then this one is min and max, min and max for our UVs. All right, so there's our triangles and our vertices. I'll give you guys a second to look at that. Okay, so we can go if current font is equal to 0. We're going to go m-batches dot pushback std make shared. Here we're using our text batch. And we can go text batch, and it's going to have the offset, and that's going to be equal to the offset. Then we're going to have the dot num vertices. That's going to be equal to 6. Then we're going to have our font atlas dot font atlas ID is equal to text glyph dot text glyph font atlas get font atlas ID. Cool. Let's clean this up a bit. This can go up here as well. Down here, so else if we want to check to see if the font atlas ID is not equal to prev font ID. And if it is, we basically want to do the same thing. Make a new batch. Else, we just want to go m batches back num vertices plus equals 6. All right. Then we can go current font plus plus pre font ID is equal to text glyph font get font as ID, and then the offset plus equals 6. All right. So if we've got here, now we want to move to the next line. So move to the next line. So we go temp pause dot x is equal to text glyph position dot x. So we're moving it back to the original x position and then down a line. So temp pause dot y is equal to text, actually it's adding plus equals text glyph font get font size plus the padding text glyph padding. That'll give us a nice space in between of our lines. Okay, so that's it for that. That's going to loop through. So we're a bit close here. So what's happening here? We didn't do any of the chunking for the wrapping yet. We'll get to that. Let's just at least see if we can get some text to the screen. So now what we're doing is we're looping through all of our text chunks, then all of the strings that we have for each chunk, and getting each character and adding that in as its new sprite to be rendered to the screen. Okay? So after we get that here, now we have to do our binding. So GL bind buffer, GL array buffer, and we need to get VBO. Then we need to go GL buffer data. GL array buffer, and that's vertices dot size times size of vertex, saying a null pointer for the data here, and GL dynamic draw. Then we can go GL buffer subdata, GL array buffer, 0 for offset, vertices dot size times size of vertex, and that takes in our vertices dot data, and then we just want to bind 0, bind buffer, that's GL array buffer, and bind to 0. Cool. All right, I believe that's everything. So let's just try to build this just to make sure it builds. Looks like we got a few errors coming our way. So we've got some errors here for our batch types. Probably this, because we didn't include string. So it doesn't know what a string is. So we can go back here. I can probably remove string from there. Here and build again. Awesome. So that built. So let's actually do a test. See if it actually works for us. So now that we have our text batch renderer, let's go to our renderer. Sorry guys, this is going to be a longer video here. So we go to our renderer here, and we want to create our text batch. So here we go text batch renderer. Add that in here. Cool. Change this to our text batch. So down here, we can add in our DrawText. So we can go void DrawText. Now we have to use DrawText2D because we're using the Windows API for us. And Windows already has a function called DrawText. It's a macro, and it means DrawText W, or for wide. And kind of a pain in the ass, but I've been wanting but we have to do it that way, and we have to go const text reference text. Now, we don't have the primitive yet for text, so we got to go create that. So let's go to our circle primitives. Right below our circle, we can go struct text, and that's going to be GLM, oops, not FLM, GLM, vec2, position, start at 0, std string, text string, then our wrap float, -1. Then we have our shared pointer to the font, p font, start at the null pointer, then our color. Cool. Go back to our renderer, and we can add in a text bunch, mtext. So our DrawText is basically going to do the same thing as the other draw functions. So let's open this. So our DrawText is just going to go mtext dot pushback and just going to push back the text. So we got to create one more function, and that's going to just be void DrawText. That's going to take in a shader. Speaking of which, we got to create the shader for this. And it's going to take in the camera as well. So right now we're just going to use the same camera as everything else. However, if you want to create UI, you need to make its own camera, its own UI camera. So if the camera is moving, the text just stays where we want it to be. And we got that. We got to change this to say draw all text. Okay. So just like everything else, we can copy everything here and paste that in and see if text is empty. There's no need to continue. Get the matrix, enable the shader, projection, and we'll change this to MP text batch, MP text batch, add text, and we have to adjust this to be text.textString. Oh, sorry, change this as well. And text text string. Second is font, text font, position, the wrap. Oh, we have padding in there. We're just going to put 4 in for padding for now. The wrap and the color. Change both of these to text batch. All right. And then here we're going to want to clear our text for our clear primitives. Okay. So let's see if we can get some text to draw. So draw text here. Let's take this function. And actually, let's just take this here. And just go to our application, see if we can get some text drawn to the screen. So application, right here. So we have our font, so text. Let's get the font. Auto p font is equal to asset manager get font. And that's pixel. And then we're going to have to do the renderer. Renderer, DrawText2D. That takes in a text object. So let's add text. Whoops. And it doesn't know what that is because it's a Scion rendering text. Cool. And text is the text string. And we're going to say this is some test text. takes in the position. Wait, 1 second. Let's just make sure, go to our primitives, and we'll just copy all this over. Go back into our application.cpp. Just paste this for now. So yeah, the position, and we'll put this at GLM Rect2, just 100 for now. So I'll put it at 100, 100. After that, oh, so it looks like position is actually first, and then the text string. Text string and wrap we'll leave, and then we'll just put the font in there. So P font. P font is equal to P font. All right, and the color can stay white for now. Actually, yeah, we'll leave it as white. And let's get rid of all that. Okay, well, we're not done yet. We need to call that right here. So let's go render, draw all text. And that'll take in our font shader and our camera. Now, we don't have the font shader, I believe. So let's take a look. Font shader is equal to asset manager, get shader, font. All right, did I create a font shader? I don't remember. Nope, we did not. So here, let's just copy this as well. This will be the font shader. Font. Fail to add the font shader. Cool. Now we actually have to make the font shader. So in our editor here, in our shaders, do we have the font? Nope. So here, go add, new. I guess CPP is fine. Font shader dot vert. Add another one. Font shader dot wrap. Cool. So let's go to our font shader dot vert. And we need to do our version first. So version 450. Then we have our layout. Location is equal to 0. In vec2, that's our position. Or you can do a position. I see a lot of different ways to write it. Layout. Location is equal to 1. That's our color. Then our UVs. Position 2. Then we have our uniform. And that is a mat 4. And it's called U projection. Then we have our out. So out vec4. We need to send out the color. That'll be the vertex color. Actually, let's do it like this. Vertex color. And then we need to send out the vertex UVs. Vertex UVs. So void main. GL position is equal to U projection times vec4 position.x position.y 0.0 1.0. Then vertex color, that's the input color, and vertex UVs is equal to the UVs. Let's call that UVs. Cool, that's the vertex shader. It's pretty straightforward. Let's go to the fragment shader. And it's the same thing here. So version 450 core. Then we have our out, which is the final color, but that's also a vec4. Then we have our ins. I'll put those first. In vec4 vertex color. In vec2 vertex UVs. And we're going to have 2 uniforms as well, and those can go right here. Uniform. Actually, we'll just have the one uniform. Sampler 2D. That's going to be the atlas. And then our final color. And then here we go, void main. So now we want to go vec4 pixel color is equal to vec4 1 1 1 sends in the texture of the atlas and vertex UVs. And we want to get the red because that's what we're using for the mask. Then we go final color is equal to pixel color times vertex. All right, that should compile. So let's just run it. And so we have our shader. Let's go back to our, make sure we're doing it all correctly. Shader font down here. Looks like we have an error. Yes, fix that. Font shader, calling font. All right, let's try it. If it works, actually, before we do that, let's go to main.lua and get rid of these for now, and get rid of all these loading of the assets as well. Okay. So all we should see is some white text on the screen. Hopefully. Okay, so we got errors and our primitives. Doesn't know what a font is. Try again. All right, so it's still unhappy. Text string, unknown specifier. All right, so we got some failures in our font compilation, and that's fine. So where is this? Font.vert, vertex, vertext. That'll do it. Vertex. So we go to this. Try again. Okay, so we don't have any text. Now I got to figure out why. Oh, I know exactly why. Because we're deleting the text. We're only drawing it the one time. So we're clearing the text. So let's go back into our renderer. We only make the draw call the one time. Sorry. We only make the draw call one time, but we're clearing it here, our primitives. So let's just comment that out for now and see if it works. Still nothing. All right, so now I got to figure out why. Let's go to our text batch. So it didn't stop there. That means no text is being drawn. Let's see here. Draw text is not being called. So let's go back to the application. That's where I added draw text in. Draw all text right here. What the heck? Ugh. Man, if that was the issue, I'm going to be pissed. It was too. Okay. So yeah, I had it clicked in here, and what that does, it will prevent you from executing anymore until you hit enter on the console or close the console. Sorry about that, guys. So unexpected here at line 16. Oh, silly me. Sorry, guys. I keep hitting 4. That's a 2. All right, so we're drawing text. Text is not empty, it's got 1 in it. And we have an error, that's fine. Let's see what it is. Draw text. Batch is clear. Batch is clear shouldn't be an issue. Stop. Run again. Oh, yeah. So there we go for rushing. Of course it's going to be not do anything. It's still null. Huh. Sorry about that again. So let's actually get rid of all this here. Sorry. Trying to go too quick and I'm forgetting what I'm doing here. So we need to go np text batch is equal to std, make unique, text batch renderer. Cool, that should work now. Could probably do that all in the initializer list, but that's okay. And we're still not drawing text. Now we got to figure out why. This is some text. P font is not null pointer. Font was loaded. Shader coming in. Is the font shader. Compiled successful. So add text. Text if. Generate batches. So what's in our text chunks? Size 1. Cool. I must be missing something. Data. That looks correct. We're not empty. We only have 1 batch, which makes sense. All right, guys. Sorry about that. So I ended up figuring out what the problem is. The problem is actually when we're loading the fonts, I forgot to bind the texture here. So if you don't bind the texture, it's not going to do any of this stuff for us. So we need to bind it so it does all, it sets all these parameters for us. Okay. So I did that for both the load font or create font and create font from memory. Now we're not creating one from memory right now, we're just loading the file. But if you run it, it should work now. All right, see, so this is some test text. Doesn't fit on the screen because it goes beyond our window, but it's working now. Okay, that's it. That's actually getting some text to the screen. All right, so that's the text rendering right there. So we got our text batch and we're loading in fonts from files and we're able to run it and get our text going. So that's it for this video. In the next video, we're gonna actually do the wrapping of the DrawText function into the renderer bindings here. So how about, as a challenge, you guys try to do that yourselves. See if you can do the wrapper function here and draw the text from the Lua. Also, as another little test here, see if you can figure out how we're going to do the text wrap. So we'll wrap down to the next line, because if you run this here, we could have this wrap down to the next line because there's more text there that we can't see that's off the screen. Okay, so that's it for this video. Keep tuned for the next one. It should be coming out shortly, and take it easy.